Hello, assalamu alaikum. Good evening. Masā al-khair, everybody. Welcome to another session with me on the digital days for MENA. Today's session, another session on Google Cloud, a security topic today. So we will cover one of the services on GCP, Cloud Armor. So network security in Google Cloud using Cloud Armor. So before I cover the topic of Cloud Armor in particular, I'm going to talk about a little bit what is there, what do we need Cloud Armor, what are the features, and what is it there to solve for us. The main reason why we are using or we'd like to use Cloud Armor is DDoS attacks, so distribution denial of service attacks, which are really a major concern, not for just users, but for big corporations, big companies, because they can have a huge potential fatal impact on the security, and hence it's going to be have on reputation of the company, impact on the business, especially if you're not really prepared for that. And this is kind of the main thing that really makes the news on a regular basis. If you check BBC or any tech websites, big companies, that's the first thing that makes the news. So we're going to cover how actually DDoS attacks work, what are the things that are available for us in GCP without us to make anything, without for us to configure anything, that GCP are taking care for it for us, and then we'll dive in and talk about Cloud Armor as a layer of security that we have complete control, complete kind of flexibility into configuring according to our security requirements. So how does DDoS attacks work actually? So a distributed denial of service or a DDoS attack is basically a malicious attempt to disrupt normal traffic of a targeted service, targeted application, a targeted system, or a network. And the way it works is overwhelming the target from different location, and basically try to overwhelm it with flooding it with constant internet traffic from a distributed set of sources for multiple locations. So the service or the system or the application or the targeted service or the network won't be able to handle the traffic at that kind of rate that is coming. And this is basically what it would look like. So so in the diagram here, what we're seeing, basically the attackers or the hackers or the ones who are responsible for this, basically what they do, obviously most of the times they won't have the capacity, they won't have the infrastructure to do all this kind of service across multiple locations, geographical locations across the world. So what they do, they infect computers and laptops, which they become like what we call botnets. So basically the first step into doing a DDoS attack is to infect servers, laptops, systems, networks, by spreading some kind of malicious software, either through emails, websites, social media. So the idea is the user will be clicking on a piece of a link that will download a piece of software into their device without them realizing. Once their device, the laptop or server or whatever they got to, was successfully installing that piece of software, malicious software, they will become basically part of that network that's going to be used to do the DDoS attack. So these machines, once they're infected, basically they would be controlled remotely without the user realizing they have been controlled with that piece of software that is infected their laptop or their server or anything. So they won't have any knowledge of that or whatsoever. So the network of this attack will grow by the rate of how many of these laptops have been infected with this malicious software that was sent by email or a link that was distributed or anything of that sort, really. So, and once the bigger is this network of infected devices, the more powerful the DDoS attack is going to be. And they are then basically used like an army to launch the attack against any particular target. And some of them they can reach to millions of machines to have this powerful network or this powerful kind of network of that would be part of that malicious attack to do a DDoS attack. One of the famous ones back in the 2017 or something like that, there was a major DDoS attack that was in the strength of around 1 terabit per second. That was massive attack, DDoS attack. If you just Google that, DDoS attack to 2017, and you will figure out. Probably gonna get a list of those according to the damage that they've done. But like I said, the more the malicious, the more infected are those machines and laptops and systems, the more is gonna be. So let's have a look now. How does Google help us? GCP in particular. What are the mitigation techniques that are provided? What is there available and provided for us without us to doing anything, and all the layers of security that we can take and we can leverage in order to protect ourselves from DDoS attacks. So when you build an application on the premises, you will be responsible for everything from security perspective. So you are responsible for the physical security of the hardware, on the premises, through the encryption of the data of the integrity of the network, all the way up to the security of the content stored on those applications, including taking care or protecting against DDoS attacks. When you move into Google Cloud, the security is a shared responsibility between Google and the customer, and that would be depending on what sort of service the customer would be using. Let me just get my there's a pointer here. So an IaaS, or what we call infrastructure as a service, this is where you will have a VM, for example, you install your application. So the lower level of security is the customer responsibility. From the guest operating system up to anything on the top of that will be the responsibility of the customer. The patching, the application, the code they're going to be deploying, and so on and so forth. So DDoS attack will be DDoS security or DDoS protection will be responsibility of the customer. Obviously, Google, they're going to give you the tool to leverage and to protect those in Google Cloud. Because what we're saying here, anything that is in green, which is responsibility of Google to protect those layers of security, and this is what we call security of the cloud. Anything that is in blue, depending on the service that you're using, this is security in the cloud, and this will be the responsibility of the customer. So moving into things that are platform as a service, something like App Engine, like BigQuery, something that is managed by Google, the less security into it's basically managed by the customer, and more security is managed by Google, because we have here less access or less control, less responsibility for the infrastructure that is running those applications. Still, we move into things like software as a service, serverless services, those kind of stuff where we don't have to provision anything, and mainly the responsibility of the customer is to have this governance over, let's say, who do I need to give access to my data, but the rest of it is taken care by Google, which basically saying specifically when we are talking about DDoS attacks, that would be responsibility of Google. So layers of security. So when we want to create, deploy secure applications, there is like multiple approach that we're going to take in order to protect our application from vulnerabilities, any attacks from outside our network, and these layers start from the top level here. We talk about load balancers. So the load balancers, that the first kind of layer of protection, because this is especially if you have like front end or customer facing web applications, the load balancer will play a big role in there. The second thing is the attack surface. So the attack surface, basically, the more I've got my availability and my resources are available across the globe, the wider or the more I have, the bigger is my surface of attack to customers. So in that sense, what we would like to do to reduce the surface of attack as much as possible, just to gather to cover our requirements. Internal traffic, which basically we are here. What we're saying is, whatever virtual machines I have in my network, I don't have to give public IP addresses. Make those VMs publicly available in order to access external services and things like that. So the minimum access to public is the better from that sense. And then API management. Obviously, I need to control my APIs that are facing the internet. CDN is another service that we can leverage. We're going to talk that how that's going to help us. Content delivery network. How's that going to help us to from DDoS protection perspective, and then we might deploy other layers of security that are specific to protect us against DDoS attacks. Things like Cloud Armor, which we're gonna talk about, and how that can help us, and hopefully we'll get a chance to do a demo about that as well. So like I said, leveraging Google load balancers, and then we can reduce the attack surface, isolate our internet traffic with not providing IP addresses to public IPs to our VMs, Cloud CDN next, the API management and monitoring, and then the Cloud Armor bit. How do we leverage that to protect us against DDoS attacks? So the load balancers to start with. So the load balancers in GCP. Remember, we talked in a couple, maybe 2 or 3 sessions when we talk about the Google network. Is a global network that basically sits on the fiber network that Google have globally, and on top of that, we've got a layer of software-defined network that spans the globe. So the load balancers, they sit on the same network. So the global load balancers, they provide built-in defense against DDoS attacks by default. So we don't have no additional configuration is required. So when you place a load balancers in front of your services or applications, that's the first layer. So without us to do anything, first of all, if you are using HTTPS load balancers, the first thing that is as a protection, anything that is not HTTPS will be rejected outright in there. So that's the first layer. Second thing, from DDoS protection, those load balancers, they are by design. They are designed to protect against DDoS attacks. And the way they work, in a nutshell, basically, if there is a particular attack coming from a particular region or IP address, the load balancer automatically has got the intelligence to throttle that traffic that is coming. So it will completely slow it down. If it notices there is like an attack, there's a big rate of traffic coming from one location. And if it surpasses a particular threshold, it will be completely blocked. So load balancers, they got the DDoS kind of DDoS protection by default in there. So as a customer, somebody who's using GCP, we don't have to do anything in there. That's already there for us. So we can leverage the load balancers in order to do DDoS mitigation as a DDoS mitigation service as well. So if the system detects an attack, like I said, it will automatically configure the load balancer for us to drop or throttle that traffic. And then talking about reducing the attack surface means reducing how much exposure our VMs have on the internet. So basically those applications that we host on VMs in Google Cloud or Compute Engine instances, and they require kind of network communication on the same VPC. If those resources are related and you don't require network communication among themselves, just put them, segregate them, use different VPCs, different networks. They don't need to talk to each other. That one kind of best practice that we can do in order for those to isolate them. And if they don't need like accessing the internet, for example, or something like that, then we don't want to put public IPs on them as well. Firewalls, so you can control individual ingress and egress traffic for compute resources using firewall rules. So any VM, I can block traffic coming to them. But the problem with that is if we are doing firewall rules, the calculation will be done at the leg of the VM, which means traffic is already in my network, so I haven't blocked traffic outside my VPC. So if I'm not leveraging capabilities of or any other services, the traffic is in my network. It's reaching to the level of my VMs. So we can use firewall rules to block unwanted resources. I'm just leaving a particular IP range sources. Let's say I've got I'm using an application in GCP. I want just my users in my data center or a block of IPs that I want to allow. That's also possible. Or I can use things that we talked about before. Leverage the tags and service accounts to control what is allowed, what is not allowed, in order to communicate with my applications that I'm controlling on my VM. Public access to internet to internal traffic. So, like I said, we don't avoid using public IPs on VMs unless you need to. So one best practice to do is to use bastion host. So use one virtual machine as a jump box, give it a public IP. Um, anything else then uses internal IPs. So in that case here, I've got just one VM with a public IP, and then I can control access to the internal VMs. And I'm going to use again the firewall rules here only to allow traffic that I need to talk to my network to access this bastion host. Otherwise, anything else will be rejected. So only one bastion host who has got a public IP. VPN is another one that I can use and leverage in order to control and have secure communication to my VMs internally. Cloud CDN. So we talked about Cloud CDN before. So the content delivery network, and we spoke about it. That is the reason we use CDN. Beyond talking about security, is to cache content to make it closer to users. So for latency purposes, and Google, they use it for YouTube. So, and this is rarely you're going to see things like latency or buffering of videos. And because if somebody uploads a video on YouTube, um, it does get cached in over 100 locations across the globe. Let's say somebody is uploading a video in the US, North America, for example, and somebody wants to watch that video or stream that video who is in Australia. So you can see we are the other side of the globe. So the reason we use the caching, we don't want the user to be basically streaming the video across all the network, because there'll be a big latency in there, so there'll be buffering. It's not a nice user experience, really. So CDN will allow these videos to be cached across all the globe, and one of the CDN locations is going to be in Australia. So the user will be streaming that video from the CDN location in Australia, and that's why they wouldn't notice any latency. And the very same service here, it's used in actually in Google Cloud. So we have CDN that you can configure with load balancers. It's just a matter of a tick box that you're gonna specify, and once you do that, basically you are caching content across the globe. So how does that help us in terms of DDoS attacks? The way it helps us, because it sits on this massive network on the globe, the content is distributed, is cached across the globe. So if you have an attack, that distribution on that caching of content will absorb any attack, so that you won't find anything that will be able to to overwhelm your content across the globe. In fact, you won't be able to get to the back end of that data because it is distributed, it is cached in multiple locations. Somebody trying to attack that, it will be basically distributed across that, and thus you'd be basically over kind of absorbing all that attack across the world. So it does naturally reduce the load on your origins, even when there are no attacks whatsoever. So this is kind of you get it by design as well. If you use CDM, you're already using capability to absorb DDoS attacks in there. API management. So, and this is for developers and things. So for IT, network, DevOps teams. So allowing access to the backend services is often required to basically facilitate interaction between applications, services, customers, business partners, those kind of things. So putting API gateway or an API management in front of your backend services can help you prevent denial of service attack. So if you see an attack, do the same thing as we do, as Google do with load balancers. Basically, if you see requests above a certain limit per client that is coming, you can start to throttle the requests, or even if you go particularly above a particular threshold, you can even cut off that connection completely. You can manage the control access to API from a single centralized location. And then you will have, with the API management, you will be able to monitor, track all the API usage. You see all the requests, the rate of the request, and the rest of it. So and Google Cloud give you two options. We have cloud endpoints, and we've got a PG Edge as well, which we might have a specific session about them in the future, specifically for developers. So talking about all those all the things that are available for us to kind of we can leverage. Some of them, they are already by design for us, like I said, Cloud CDN. Don't have to do anything. The load balancers are in there as well. The APIs can help us with that, and then we can do other things on top of that, firewall rules and stuff. Particularly on the firewall rules, on the using firewalls. Basically, like I said, one of the disadvantages is the calculation of the traffic is happening at the level of the VM. So talking about VPC, my VMs are already in the VPC. So if I am allowing traffic to go through, I'm already pretty much maybe in trouble already. So the idea here, if I want to put a layer of protection the closest to the attack, so beyond my VPC, so the closest to the attack is the better. So I want to protect at the kind of at the edge of my network, and this is what DDoS gives you, or the Cloud Armor. Sorry, so Cloud Armor, which is a DDoS and application defense service, sits on this global network again. So we're leveraging the capability of the network. It's completely distributed across the globe. It delivers defense at scale against infrastructure, web application distributed denial of service attack using the global, the Google's global infrastructure and security systems that are used. So it is software defined, and we can do a lot with it. So similar to CDN, Cloud Armor protection is delivered at the edge of the network, and it can block these attacks closer to the source of the attack before they even have a chance to affect anything inside my network, or they won't be able to reach my applications at all. So Cloud Armor works beautifully with the global HTTPS load balancers to give you another layer of protection from of DDoS attacks, and it enables you, like I said, with the load balancers, it's there by default, but I don't have any level of customization. DDoS Cloud Armor gives me the level of customization. I can configure it to mitigate multi-vector attacks. I can enforce access control to allow or restrict user traffic based on IPv4 addresses, IPv6 addresses. I can also do things like I can block geographical regions. So if I have a concern about traffic coming, for example, from a particular country, for example, I can block the entire country. I can say this geographical area, I don't want to receive any traffic from them. So it also works with security offerings from third-party products as well. So it is a comprehensive security model for your GCP services as well. So you can, like I said, you can blacklist, you can whitelist, depending on your requirements, where is traffic coming from, different layer of customization. So complete control, granularity into what I want to configure, what I'm allowed, what can allow to traffic to come in and what is not allowed and things like that. So this is like a screenshot of doing that on the Google Cloud Console. It works with security policies, which can contain different rules, and the rules basically what we're seeing here is basically saying what to do, what the action is to do, under which condition. So here you can see allow or deny. What is the IP addresses that I'm allowed? It also what it does, it provides several predefined rules to defend against things like cross-site scripting, SQL injection, LDAP injection, application-aware attacks. All those you can get them by default. So let's have a look at a quick demo here, and I will show you. Please, if there is any questions, or please put them in the chat. I will check on that. But in the meantime, let me just switch to the Google Cloud Console. So this is the Google Cloud Console. What I have here, I have a load balancer. I've created a load balancer here. So if I go to my services, the network services, let me scroll down here. Load balancers. So I have a load balancer here. And on the back of the load balancer, I have an instance group. So probably that instance group, I have my application in there, and I'm load balancing traffic coming to my load balancer to these 3 web servers. So I've got 3 web servers, and in front of them, I got a load balancer, and this is the IP address of the load balancer. So if I check this, if I go to, you can see here the web server, this server zone, it basically proxying my request here from load balancer to one of the servers, which is in US Central 1 F. So this is my load balancer, absolutely fine. What I'm gonna do now, what I will do, I will create, first of all, a virtual machine. I'm gonna create it in a completely different region. So the application is in the US. Let me just go and create a virtual machine in Australia, for example. So I'm gonna go, let me just take that out. And I'm gonna create a VM instance to try basically to block traffic coming from that. So at the beginning, I'm not gonna set anything. I'm gonna allow this virtual machine to access my application through the load balancer. So if I go to, yeah, let's go with Sydney. And I'm gonna use everything as default. And I'm gonna do next, I'm gonna SSH to this machine, and I'm gonna try to access those the web server that is sitting behind the load balancer. And that's going to be through the IP address of this. So I'll wait for this to come up. Okay, gonna SSH, connect. Let me grab the IP address. Cool. And you can see here, maybe making this server is in zone, US Central 1. So I'm allowed to do that. So I can reach from this VM, which is in Australia, into that VM that is in the US. So I'm gonna go do now. I'm gonna create a rule using Cloud Armor in order to block traffic coming from that VM into my application that's sitting behind the load balancer. So if I go to network security, I go to Cloud Armor. I'm going to create a policy, and I'm going to do a block list access test. I call it that. I'm going to do a backend. I'm going to set the default rule to allow. I'm going to add a rule, basic, and I'm going to use the IP address of this VM. So if I go to VM instances, so the IP address of the VM that I want to block let me see. Yeah, so this is the public IP. So I can copy that. And this is the one I'm going to block. I'm going to do deny. I'm going to ask for a message. And this is just, I'm not going to put forbidden. I'm going to put not found. And not found, basically the person who's going to access is going to get this message. So it's going to confuse him saying, okay, I didn't find this resource, doesn't exist, rather than saying him forbidden or denied or anything like that. So this is a good message to give back, actually. So what I can do next, so I'm denying that, this IP address. Okay. Yeah, I need to put 1000 priority. Next. Now I'm going to apply it to the target, and my target now is the load balancer. So if I go add the target, load balancer backend, this is my load balancer. So what we're saying here, if traffic is coming from the IP address of that VM to my load balancer, basically block it and send the message 404 to say that the service is not available. I'm going to be doing done, create policy, and I'm pretty much done. Now remember, this load balancer is services is globally available. The Cloud Armor is also globally available, so it is distributed across the globe. So whatever I'm applying here, it does take a bit of time. I'm not configuring an appliance, so this configuration is going to be distributed across the globe, across all those locations. So in order for it to take effect, is gonna basically take a bit of time here. So if I go back to the virtual machine, probably if I'm going to do the curl again, Yeah, it's gonna take a little bit of time here. So I'm gonna give it maybe 30 seconds up to 1 minute and apply again, and we're gonna see that deny message again. Now this is the very basic configuration. So basically this is our first session of Cloud Armor. What's that form? Um, the next session is going to be part two of this, where we're going to take it to the next level. We're going to do a more kind of involved configuration and the rest of it. So yeah, this is hopefully the first part of it, and the next one is going to be a more advanced, taking the Cloud Armor to another level, where we're going to see more features and more configuration for that. So if I do a curl again, yeah, it is gonna take a bit of time there. So bear with us on this. In the meantime, let me check if there is any questions in the chat. Can't see anything in there, but let me put uh, a couple of links in there, useful links. Um, the official documentation for Cloud Armor. Uh, Let me put that there and ask if you can share this. And the second one, a really good one, is the documentation. There you go. Yeah, if the team can share those on the chat, that would be super useful. And let me go back here and see what am I doing with my route. So it is still still getting distributed. So it's eventually it's gonna apply that globally. So and okay, I think the links are in the chat now. Yes, thank you for that. Thank you for sharing that. Okay, let me SSH, take another SSH session from here. Connect. It will work eventually. Let me see. The other thing that you can do with that is the blocking regions. So if I go back here, in the rules, there's a policy in here where I can. Just checking the appliance of this. Yeah, it looks like a region. I need to do it programmatically. I need to run a command to do that. So we will do that in our next session to how to block a country, complete country or a region. I still not. Yeah, it does take a bit of time do to apply the configuration. Checking the rule again, just to make sure we haven't missed anything here. Then we go there. Just double checking. It usually takes a couple of minutes. So I've got this rule here. The IP address, just making sure it's correct. 34.151.76.9. 34.151.76.9. This was a copy and paste anyway. So that's fine. Deny. So the target is my back end, which is the web, which is fine. Let me just do that update. Come back here. Wait for another 30 seconds for it, because configuration is absolutely correct. There is nothing, no issues there whatsoever. Checking status. Anyway, I did run it earlier, and let me show you the message. I saved the message. The message should look like this. Let me share it because it's taking a long time here. So the message that I'm sharing it here. This is what you should be getting. You should be getting the 404 message not found. So I'm sharing it there. It's still not happening on my VM. Let me see. Close that. Okay, from my machine, obviously I can still access it, but yeah, there you go. So can you see it here? So now it's happening. So let me make this bigger. So you can see here, before I was accessing it, you can see the service in zone, but now I'm getting this message. So let me copy that again. It's the same one that I've shared, but now it's coming from my machine. So this is the second one. There you go. So if you can share that message again, if it's not, if you can't see it from screen, this is what we get in here. This is the message. I appreciate probably the window is too small, but I'll try to make it bigger here. But I can't scroll in the. So in this little exercise, basically we apply the rule to block traffic at the edge of my network with the load balancer rule to block that VM coming from Australia into my application that sits behind the load balancer that we're accessing through the IP that is in the US. And with that, I can't see any questions in. Seeing message from Saif. Yeah. So the IP address of the IP of the load balancer, this is the one that I'm trying to access from the VM that is coming from Australia, which is now blocked. It's not allowing it anymore. So before it was, and then now it isn't. All right. Thank you very much for being with us today. If you have any questions, you can reach me on my Twitter. I'll share my Twitter account or my LinkedIn. Happy for you to. So that's my Twitter account. Let me share here. And my LinkedIn. If you have any questions, you want to reach out, I'm here to answer any questions. Or there you go. We ask the team to share my links in there. Thank you very much for being with us. Thank you, and have a good rest of the day, and see you on the next one. Our next session is going to be part 2, Cloud Armor. Thank you so much. Take care. Assalamu alaikum.